Speaker is not working. So first of all, we have to understand that what is the function of a wedge. So wedges are used to make a very small adjustment in height only, for any heavy object. Suppose, for example, if I want to say, suppose there is a very big object is there, okay, for example, 1000 Newton, hmm, and you have to move this in the upward direction a little bit. Huh? This is the wall actually. Sorry for my bad drawing actually. This is also a plane, straight one. Now suppose you have to make this one move in upward direction. So how to do that? Here first consider there is a wedge, hmm, that is one wedge, that is another wedge, and consider this angle is very small actually, huh? This is considered as a 6 degree only, for example. And if you push na, means if you applied force by hammering or something, then it will move in the upward direction. Okay, means for very small adjustment we have to do this. Clear? Now so the force required to lift the object is usually much smaller than its weight. What does that means? That means the P is very less compared to if it is we consider as W, it is like that. Understand? And the force required to lower the object is also smaller. Suppose you have to do, means what can I say, suppose you have to remove these blocks in such a way that it will come in the downward direction, na? So there also it required a very less force. So this is the actually function of any wedge. Now during this motion, means if we put apply force, then in this intermediate surface, na, this surface, also this surface, na, in this surface there have some created a friction, right? So so what we have to do, first make the free body diagram. Okay, so to make the free body diagram, for example, this is body A, this is body C, this is body D, and this is the surface. We consider this as a B, wall and the surface both. If it is like that, then what is the free body diagram? Free body diagram for C body, means this one. For this one, what is that? Very simple. Draw this body, applied force is P, the normal load that is N1, and if it put, means applied forces in this direction, means the body move also in this direction, means along this direction. So the friction always opposite direction. Okay, so we consider this one as a F1, and there have some angle I told you. Suppose this is 6 degree, then the normal is also have some angle, right? That is N2, and it is also have friction, that is F2. Okay, What is the free body diagram for body D? Here in the friction is the opposite for that another body. Okay, so these are the case. And what is the free body diagram for this load that is a? That should be like, student, please also write down this thing also, otherwise you may forgot. Here that is W, here it is N1, in this direction it is F1, and as the body is tends to move in the upward direction, so the friction is also here in the negative direction, right, downward direction, and the normal is on perpendicular to the body. So this is your free body diagram for the case, which case, if we consider this one as a case 1, that means raising the block, this 1000 Newton weight block we have to move upward, that is the raising a block. So that is the case 1. Okay, understand, student, up to this is it okay na?
Yes, sir.
Okay, now suppose another condition, that is case 2, if we consider the block under self weight and self locking, means
Yes, sir.
suppose that block under self weight and self locking wedges. If it is the condition, what does that means? That means the weight, that is this W, means 1000 Newton na, W, and if we keep this body as a self-locking, it means if have a tendency to move downward. Self-locking means what? Self-locking means we have to resist the body to move from the downward motion, downward direction movement. So in that case, what will be the friction? The friction is in the upward direction, right? And the normal is also same, and the friction between the body A and the body C is same, right? So the frictional component also same, and the for body C, that should be body C, see here very minutely, for body C, the N1 it is, this is your F1 na, this is your applied force. But here in the previous case you can see your body we have to apply a load na, but for the lowering case we do not want to put any applied load, because we have to move our body, means we have to resist our body to move in the downward direction, so, due to the self weight, right, and self locking. So there what we have to do na, there should, the friction should be in such a manner, and the coefficient of friction should be in such a manner that the friction acted on the body opposite with respect to the previous one. So here if it is N2, then the direction of F2 is in this direction. See here very minutely that in this case the friction is in the opposite direction, means that when we apply the force, then the frictional force is in the opposite direction in both surface. But when we do not apply the load, then what happened, to resist this body in this position, okay, we have to apply such coefficient of friction so that the frictional force which is acted on in this direction, clear? So here if we say that for this body they have created some velocity triangle. What are that? Now this is your normal n1 which is acted downward. This is your n2 which have certain angle na. This is due to this angle. This is 6 degree. It is as I told. So there also have some angle, and the another vector. This is a velocity triangle, right? Sorry, force triangle. So another vector, that is the f2. So if we draw in the enlarged view, we can find out that the n2 component and f2 component is the combination for the n1 component. Okay. So here we can see, or we can say here that for self locking it means there is no, for self locking there is no n3 which is acted on the body. Okay, no force acted on the wedges, because it is a we restrict the wedge, or we restrict the block at that position, so there is a no n3, so there is a no f3. So n1 is nothing but the its own weight. Clear? And if it is, then f1 is also 0. That is, no friction is required to keep the block A on C. Okay, this is the A block and this is the C block. There is no required of any friction. It means F2 is less than the static friction. Okay, so this is the condition. Understand? So up to this, anyone have any question, student? Is it clear? Up to this, is it clear?
So once explain case 2, sir.
Case 2. Okay. See, in the previous one, actually, case 1, it is the raising a block. We have to move this block in the upward direction. For that, we have to apply some force so that it move in the right direction, right? In this means right side, so that it can move in the upward. But for case 2, the condition is what should be the friction acted between these two surface, intercontact surface, what should be, so that this body or this block is not moved in the downward direction. Means we have to resist or restrict this block to move in the downward direction. Okay, so means we can say this thing as a the block, and due to its own weight, or we can say the self weight, it is automatically self locking. So what is the necessary requirements for that? Means due to its own weight it is not move in the downward direction. So in that to just satisfy that condition, what we have to do, that is the case 2. So if it is, then means we restrict this block A to move in a downward direction, so the friction is in the opposite direction. So that's why here the friction is in the upward direction, wall friction. You can see in the previous case the wall friction in the downward direction as this block move upward na? But here the block want to move downward, but we have to restrict this so that the friction is in the upward direction. Okay, now as this block move want to move downward direction, what does that means? That means these block C move in this direction. Na? If the block move in this direction, then only it is possible for this block A to move downward. Is it right or wrong? If the block move in the left side, then only there is have some possibility na, to move this block A in the downward. Is it clear? Up to this, is it clear? See here in this figure, this is the block C. So if the block C, just try to understand, if the block C, this is the block na, these have some angle na. So if that block C move in this direction, we apply force and move the block in this direction na, then only there have some possibility for block A to move down na. It is clear, right?
Yes, sir.
Hmm. So if it is, then if that block move in this direction, then the between these two contacting surface, what, why means in which direction the frictional force there? Opposite direction. So as it move in this direction, so that frictional force in this direction, right? So that's why it is in this direction. But now maybe you ask, sir, why then this is in this direction? Because as this move in the downward direction, this is the independent function na? So this is move downward, this is move first means our main intention to restrict this. So to restrict this means their friction means for the previous, just like previous case, here also we have to keep all the frictional forces in the same condition. And if it is like that, if it is maintain that condition, so the opposite means for contacting another body, that is a block C, so there the friction should be in the opposite direction. Okay, so this is actually the concept. Now is it clear? And as this body is in this position, so that's why there is no friction, no normal force and no frictional force, that because it is not moving na. Now if it is like that, so the normal is equals to nothing but its own weight of the body, and the coefficient of friction is how much, means sorry, and the F is how much, because it is self locked. So that is the F is also 0 because it is a self locking. Okay, remember this thing, as it is a self locking. So only one thing is matter, that is the F2, that is the coefficient of friction between the block C and block B. So what should be the coefficient of friction? That should be less than the static coefficient of friction. Understand? That should be static coefficient of friction into the normal. Because you know na, the reason behind this. Because if, see, if this condition is not satisfied, suppose f2 is equal to mu s in 3, then what happened? Then what happened? If it is the condition, then what happened? There is a no sliding, right? Remember, have you remember this thing? I means I already give suppose the f is equal to mu s into n, means static, means in that condition that frictional force means for this is the condition for which there is a no movement na? Suppose a block, you have applied a force, and if the coefficient of static friction mu s is there, mu s means coefficient of static friction, and in curve already told na, in graph, that it is like this, up to certain up means that is the mu, up to this portion, sorry, this is the mu, this is the force. So the up to this portion, this is the mu s, and when just that body try to move in the forward direction, also the friction coefficient of friction decreases. So that part called the dynamic friction, that part called the static friction. Already this thing are discussed na? This has been discussed in the previous lecture. So to move the body C, we have to maintain this condition only. That is, the F2 should be less than the mu s into N3. Okay, this is your body DCA. So is it clear up to this? So up to this, is it clear, student?
Yes, sir.
Okay. Now I have written now one is wedges part. So this is the wedges part. Another one is the threaded screw. Hmm? So okay, first let me draw. So uh, suppose if it is how it look, how can I draw? Suppose you apply a load here, and this is the weight came from the any body which is on that screw thread, and consider this is threaded, huh? This is threaded, and yes, total thread are there. So this part is the base actually, huh? This one is the socket. This portion is the socket. Okay, this portion is the screw, and this is the weight, and this length is A. Okay, now if the screw thread are frequently used for which purpose, you can see na, in the jack, in the press, huh? Now the analyze similar to block on inclined plane, and the recall the frictional force does not depend on the area of contact. So if it is like that, now imagine that the socket means this portion, the socket portion in the base, huh, as a spiral wrap. They have some spiral wrap actually, and think one revolution of the thread block in the spiral. What does that means? One revolution. It means, try to understand this thing, that moment P means this force, moment of force P is equal to moment of force Q about the shaft of the screw. Okay, so what does that means? The moment of shaft is equals to, we have to basically make it 0. So what we have to do, the q into r, r means which one? Okay, means here na, this is the spiral, right? So if it is, then the r is this one, huh? Means here it is up to this is the r actually, and the force which is acted due to this rotation, that is the q. So that is nothing but the load into, means applied, this is the applied load, and this is the distance, right? And another thing is there, that is the, this is your, we consider is as a l, that is called the lead. Okay, so q should be pa by r, you have to remember this thing. Okay, so if it is the condition, then mm, we have to draw first and then see. Suppose this is your actually the weight of the any body, and this is your q na, means this one, this is acted in this direction, so it is in this direction. And if see, this is your mhm, this is your theta, this is also theta, and the resultant means here actually n is acted, n is acted in this direction. So the resultant is always in which direction? If it is f, if it is n, the resultant should be in this direction. Okay, so this one is your resultant acted as a phi angle. Okay, this one, if it is, then if the condition motion to move the body upward. Okay, means what is the condition in which the body start, means using that jack move the upward motion. So that is the condition here, this one. Now here another may be possible, that is self locking. So what is the condition for self locking? The things, all the things are same, only one matters, that is the theta should be high. Means suppose the, in case this is your theta and this is your block, this is the q, this is w, this is actually equivalent figure. Okay, equivalent figure of this square threaded screw. So in that case what happened, in that case if it is more na, then your body, this is your vertical line, this is your theta, this is your theta, and in that case what happened, in that case na, if it is more na, that means your body will move, try to in the downward direction. So the and the normal is in this direction, right? So the resultant in this direction, this is your phi. So it means your resultant in this case in this direction. So the phi is how much here, this one here, phi. Clear? It means for self locking the phi s should be greater than theta. So that is the condition of self locking. self-locking condition. Clear? Is it clear? If the condition is like that, the means we can say this portion, this portion, this is not self-locking, na? So in that case, what happened? In that case, theta, sorry, phi s is less than theta. This is the condition for it is not under self-lock, means that body will move downward. Anyone have any query up to this? Have you understand or not? Hmm? Anyone have any query? You can ask, or can I repeat this thing again? Which one you want? Please tell me.
Repeat, sir, once.
Okay, okay. See, uh, this is a example of a square threaded screw. So if it is square threaded screw, what does that means? Basically, we have to find out the friction, right? So just try to understand. You know, this is a block, means this is the means how can I understand? I can show you. Suppose this is a screw is there, thread, screw threads are there, and there have some arm, and in that arm you apply some force, and arm length suppose consider at a, huh? So the P into A, that is the moment. Is it right? M is nothing but the P into A. You know, na, this one. But what happened in the this screw and socket portion? There have some contact, na, with the screw thread and this socket. Socket also have some thread. So between two thread there have some contact, and in that contact what happened? In that contact there have some uh, what can say, that is a some force application are there, because we already acted some moment. So that means just think this portion, just think about this portion, means this is the socket. Inside the socket there have thread, and the screw also have thread, so they have some contact, na, between two thread there have some contact. So if it is, then due to the moment m is equal to p into a, means due to this force, there also due to this moment there also generated some force, reactive force. So that is the q, which is acted on the screw thread. This is the screw thread, enlarged view of this one. Hmm? Enlarged view of this one. So, and if the screw thread have a diameter and with radius r, so r into q, so that means the reacted load, reacted force. So that q into r is equals to the acted moment p into a. So that's why q is equal to p into a by r. Up to this, is it clear?
Yes, sir.
Hmm. Now, if the question is like that, what should be the self-locking condition? Means without any applied, means if we applied load, though the screw is not move in the downward direction. Means suppose this is your screw thread and you apply a load here, okay, then what happen normally? Means suppose you are not design the square threaded screw in such a manner that if you apply load it move in the downward, right? Then what happen? If you apply load, automatically it move downward. But this is not our requirement. Our requirement is, though it's applied load, we gradually move this load upward or downward as per our requirement. It means if we do not apply any load, apply any applied force, means P, suppose this W is there also, but till now that thread is not move automatically downward. So that is called the self-locking, means automatically locked. So what is the condition for that? What is the condition for self-locking? The condition is very simple, that if that angle, this angle means which one, this theta is which one, this theta is nothing but this angle actually. If you consider na, this is the thread like that, right? Right, that type threads are there na. So if it is, that means what, we just consider this one single thread and draw it in such a manner. Okay, so if it is theta, then if it is theta, then what happened, means in that block if we applied load W, here it is Q, means you know this is Q here, this portion. So and in that case, what should be the normal and the resultant. So for self locking, that theta is always, theta is the angle, means this angle, right, this angle. So that theta is always more, sorry, less than the phi s, means self locking, for self locking the angle which is required for the, means the resultant which is created with the normal. This is the normal direction, this is the frictional force direction, so the resultant is in this one, and as the normal direction is this, so that is your phi s. Okay, and and this is your theta. Theta means this angle which is created, means the square threaded helix, so that is the theta. So if the theta is less than the phi s, then that is the condition is not satisfied, then that is the not, that is a not a self locking condition. Okay, means a not locking condition. In that case we have to hold the arm rigidly, means this one. In if it is not a self locking, means not locking condition, we have to keep that, we means we have to firmly uh, hold this to maintain its position. Okay, clear. So is it clear? Hello,
Yes, sir.
any confusion? If you have any confusion you can ask, no issue. Means you know, is it possible to, for you to understand that what is a self locking and what is a non locking condition? uh, is it okay or we have to discuss again, which one, means I have only 4 to 5 minutes time, so can I discuss more on this? Is it necessary for you? You can tell, no issue. Hmm? Hello. See, that is actually I told you na that this portion, this is your thread, right? I think I already gave you na one book, BRN Johnson, BRN Johnson na. So in that book, maybe page number 30 or more or less, I forgot. In that book, you can follow this thing also. Okay, for your reference purpose. So actually, this is your theta, and if this theta is less than the phi s, phi s is what? Phi s is the normal and the friction force, their resultant. You know na, resultant means what? Their resultant means if we draw the triangle, vector triangle, then that should be like this. So this is your, if this r make an angle na, suppose you draw, this is theta, so that normal is in this direction, and this is your vertical plane, and this is your resultant. So that resultant create, that is phi s, and that is always more than the theta. So that is the condition actually we have to make, so that the body is not move in the downward direction. Okay. Okay, so today I end my lecture here. If anyone have any question, you can ask, please. Anyone have any question?